Good morning to everyone. In the previous class of Electrostatics Chapter 1, we discussed about electric charges and we discussed about different properties of electric charges, as well as we have also discussed about charging, what is meant by charging, and the types of charging also we have discussed. And I think we have got a brief idea about electric charge. Now today we'll carry on our next topic of the chapter number 1, electrostatics, that is the most important, Coulomb's law. Today's topics, you kindly write the headlines. This is Coulomb's law. The first derivations of the class 12 physics, second year, Coulomb's law. So what Coulomb's law and what is the importance of it? So we'll discuss in today's class. You write down Coulomb's law. According to Coulomb's law, you can write. According to Coulomb's law. According to Coulomb's law, electrostatic force between two bodies is directly proportional to the product of according to Coulomb's law, electrostatic force between two bodies or two charges. You can write it is better, bodies between two charges. Two charges is directly proportional to the product of the charges. Product of the two charges. And inversely proportional to the square of the distance between them. So this is the Coulomb's law. According to the Coulomb's law of electrostatic force between two charges. That means we have to have two charges. And the electrostatic force between two charges is directly proportional to the product of the two charges, and inversely proportional to the square of the distance between them. That means we should have two charges, and if you consider that they have got attractive or repulsive force between them, then that force will be directly proportional to the product of the charges, and it will be inversely proportional to the square of the distance between the charges. So if you go to analyze this mathematically, as I have given the statement of Coulomb's law, so if you go to derive it mathematically, Coulomb's law. If we consider any two charges, suppose we have got this is a charges, this charge is Q1, and this is another charge, this charge is Q2. Now if I consider that this is positive charge and this is negative charge, then they will have the attraction, and if both are positive, then they will have the repulsion. Now I am considering Q1 and Q2 two charges. If you consider, I am telling you, if both Q1 and Q2 are positive or both are negative, then there will be repulsion. And if you consider one is positive and other is negative, then there will be attraction. So I am considering both Q and Q2 are positive now, and the distance between Q1 and Q2 supposed to be R. Distance between Q1 and Q2 is R. So since the Q1 is also positive and Q2 is also positive, the directions of force will be this way. If we consider, so this will be the direction of force. The force will be applied in this direction. Since I have considered that these two charges to be positive, unless this charges, this is one positive or this is negative, then there will be attraction. That means the direction of this force will come towards it, towards the center. And now this force is going away from the center. Now if I consider that this F is the force exerted between the charge Q1 and Q2, since I have considered two charges Q1 and Q2, and as you have experienced a force F here, and their distance between Q1 and Q2, that two charges we have considered is R. So according to Coulomb's law, what I can write, that I told you that electrostatic force between any two charges will be directly proportional to the product of the charges. That means F will be directly proportional to this force will be directly proportional to the product of the two charges. Which charge we had? We had Q1 and Q2. So this will be Q1 and Q2. That means F will be directly proportional to Q1 and Q2. Next, this force will be inversely proportional to the square of the distance between them. This is too simple. This force is inversely proportional to the square of the distance between them. Since you can see that Q1 is the charge, Q2 is the charge, their distance between Q1 and Q2 is R. So this F force will be inversely proportional to the square of the distance. This is 1 by R square. Now from 1 and 2 equation, we have F field proportional to Q1 Q2 by R square. Now if I take the help of a constant here, so F is equal to K, this is K Q1 Q2 by R square. In this case, this K is a constant and this K is known as this constant is known as electrostatic constant. This K is known as electrostatic constant. Electrostatic constant. Electrostatic constant is this K. Understand? So F is equal to K Q1 Q2 by R square, and in here this K is going to be your electrostatic constant, and the value of this K, that is your electrostatic constant, the value of K will be 1 by K is equal to 1 by 4 pi epsilon naught. That means K is equal to 1 by 4 pi epsilon naught. Hence we can write, therefore we can write F is equal to, in the place of K we can put 1 by 4 pi epsilon naught Q1 Q2 by R square. This is all about the Coulomb's law. F is equal to 1 by 4 by epsilon naught Q1 Q2 by R square. Now couple of things is here which you have got newly. The first thing is what? That this K is, I have given you, this K is electrostatic constant. Remember, electrostatic constant. It has got a specific value. and this k is equal to 1 by 4 pi epsilon naught. Numerically if we find out the value of k, that means the numerical value of electrostatic constant will be 9 into 10 to the power 9 Newton meter square per Coulomb square. How I have find this unit, I will show you later on. The numerical value of electrostatic constant K will be 9 into 10 to the power 9. 9 into 10 to the power 9 Newton meter square per Coulomb square. This is the exact numerical value of electrostatic constant. So far we have got the Coulomb's law. That what does Coulomb's law states to us? That the electrostatic force between any two charges is directly proportional to the product of the two charges, and it is inversely proportional to the square of the distance between them, and it can be expressed as F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is all about Coulomb's law, and in this case this is epsilon naught. This epsilon naught is electric permittivity in free space. You can write this is epsilon naught. Epsilon naught. This is electric permittivity. Electric permittivity in free space. Electric permittivity in free space. And the numerical value of epsilon naught, that means electric permittivity in free space, is exact value is 8.854 into 10 to the power minus 12. 8.854 into 10 to the power minus 12, and a unit of this electric permittivity will be reverse of this one. That means this is Newton meter square per Coulomb square, hence this will be per Newton per meter square Coulomb square. Remember, the SI unit of electrostatic constant is opposite to the SI unit of electric permittivity in free space. We will later on define what is electric permittivity, but for your basic information, that's it from the Coulomb's law. Okay, F is equal to 1 by 4 by epsilon naught Q1 Q2 by R square. Here K is electrostatic constant. I am repeating the value of this like that, and this is your epsilon naught. This is the electric permittivity in free space. I hope you have understood the Coulomb's law. That's it for today's class. Thank you.